Good morning, everyone. It's Kevin here from Skywatcher, and welcome to another episode of the What's Up Webcast. For those of you who've never joined us before, the What's Up Webcast takes place every Friday, 10 a.m. Pacific, right here at the Skywatcher USA YouTube channel. And we cover everything there is about astronomy. Because it's our webcast, we can do whatever we want. So we normally check out everything that has to do with astronomy, from what's up into the nighttime sky to equipment to helpful tips and tricks to apply for your imaging or visual use, like what we're doing today. And of course, the last Friday of every month, we have a special guest with us. So if you're new here, welcome. Thanks for joining us and happy Friday. If you've been joining us before, welcome back and happy Friday to you guys as well. Of course, if you like what we do here, we really appreciate if you could just subscribe to the channel. It'll keep you up to date with any new content or videos that we are coming out with. We've already released the March schedule of videos, which is visible under our upcoming live stream videos on the channel. You should get a notification from YouTube that something new is coming. And then we are working on April, and we've got a lot of cool stuff coming up for the rest of the year that is currently being planned at the moment. So we're always looking at adding new stuff. And of course, we're also working on new content to better support our products as well, informational videos and such. Now, this week's been a pretty strange week. I know we have a lot of friends in Texas. Hopefully you guys are doing okay out there with the crazy weather you've had. We did talk to some of our friends in Houston this morning they're getting by, so hopefully you guys are okay there. And then congratulations to our friends at NASA Jet Propulsion Laboratory for landing the new rover up there, Perseverance. I talked to a couple friends of mine over there yesterday, and they were very stoked about putting a brand new rover on Mars. So it's been a busy and chaotic week for a lot of people. So for those in Texas, hope you're doing okay. And then friends of ours at NASA, congratulations for all the efforts that you've been doing. So if you are joining us today, thanks very much. And we're going to get started. Now, today we're talking about a particular topic that I see come up a lot. And it's something that I see gets confused a lot as well, even with advanced observers and imagers to beginners. And that's really seeing conditions. But we're going to jump into this pretty quickly here. So let me just throw this up real quick. So first off, let's talk about observing conditions, and then we'll transition into seeing conditions. Because there's some factors that we have to understand about this to get us to where we want to go, essentially. So there are three factors in astronomy that we all look for. Now, the first one, of course, is darkness. We all know what darkness is. It's how dark the sky is. We all complain about how lack of darkness there is in many of these places. But I find doing a lot of tech support, I handle Skywatcher tech support, so I talk to a lot of people every week via phone and email. And a lot of times, if someone's experiencing bad images or things aren't looking that great, the first thing we're going to ask you is, how was the seeing that night? And the first thing most of the time that people say is, it's not that great. I live in a Bortle, 7 sky. And for those of you who aren't aware of what Bortle is, we did a video about dark sky sites where we reference the Bortle scale, which is how dark a nighttime sky is. 1 or 0 being the best, and I believe 9 is being the worst, somewhere up in there. A lot of people will say, I live in a Bortle whatever, or I live in a red zone, which if you look at a light pollution map, it maps it out in color. So they'll say, I don't have very good seeing because I live in X brightness location. That has nothing to do with seeing conditions. The darkness of your local sky or wherever you're viewing from is irrelevant of the conditions for viewing. It's a nice thing to have, but it's irrelevant. So, and that's why we're doing this episode today, because I find that it's a common misconception about seeing conditions, and that's kind of what we want to break through and kind of help people navigate so you actually know what seeing conditions are. So, anyway, darkness has nothing to do with seeing conditions. So, these are the three factors that we bring up in astronomy. So, darkness is the most common one. The next one is transparency, and the third one is stability. Now, these three factors are the check marks that we have to look at for certain types of imaging, certain types of viewing. Pretty much anything that we want to do navigates through these three check marks. And any professional observatory that you've ever visited or know about has to go through these three check marks. We have to figure out what exactly we're trying to do and make sure that the site or the location that we're going to be doing that from meets these criteria. Now, like I said before, darkness has nothing to do with seeing. The two factors that have to do with seeing are transparency and stability. Transparency, obviously, meaning how clear the sky is, and stability is how stable the sky is. So those are the two of the three factors that mean seeing. Darkness is just a part of that. It's kind of the cherry on top. If it can be dark, that's great. But these two factors are going to dictate how sharp your images are going to be, how good your guiding is going to be, how much you can resolve in your telescope, how sharp your image is going to look like. Transparency and stability are the two factors that will decide how those are going to look. You know, there's a lot of people out there that are like, I want to get 0.5 arc second guiding, or I want to shoot at sub arc second, blah, 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 blah. All of those factors, all of those things that you want to obtain are done through transparency and stability. And you'll find that some locations just don't support certain types of viewing or certain types of equipment. And knowing those factors will enable you to produce the sharpest images you can per your site, and also adapt your equipment to the particular type of work that you want to do. So that's what we're going to be doing today, and talking about that. So let's break down those three factors even more, because that's the big thing, right? We need to understand the three factors before we can apply the check marks to make sure we're hitting the notes that we need to hit. So number one is darkness, as I said before. Now, everybody, I think, would agree that we would love to live in a dark sky site. You know, we want to see those things big and bright. We want to take those beautiful deep sky images, blah, 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 blah. Darkness, darkness, darkness. That's about everything you hear about. And it's nice. It would be great to have a dark sky site, but just because it's dark doesn't mean it has good seeing. Now, like I said earlier, darkness does not equate to good seeing conditions. It has nothing to do with it at all. Dark sites can have bad seeing. We've been with Skywatcher, we travel around, we go to different star parties and events, and we've been to some locations that particular night just didn't have good seeing. Yeah, it was dark, that's great. But if the seeing doesn't support the equipment we brought, then all the images look fuzzy and they're not sharp, and the sky doesn't have that etched, look when you look up at the Milky Way and it just looks like someone chiseled it into the nighttime sky. That's good seeing. But it can be dark and can be garbage at the same time. Or you can be in your backyard and you can have excellent seeing even though it's not dark at all. So, some of you may have found that one particular night in your backyard, everything just came together and it was rock solid. And that's awesome. But it wasn't dark. But that's irrelevant. Darkness doesn't have anything to do with your seeing conditions. Like I said, darkness is nice, but it's kind of just the cherry on top. That's all a dark sky is going to give you. It's just a bonus. Now, if you can have a dark sky with good seeing conditions, that's why observatories are located where they are. because they want all three of those factors to apply. That's exactly why they're there. They spent a lot of time looking at different locations, finding different locations, and that site, like Mauna Kea or Kitt Peak or Mount Lemmon or any of these observatories, they are on those locations because they found that it marked those boxes where, of course, it was dark, but the transparency and stability were excellent. And that's going to allow them to get the image that they want. So, and it varies on the type of observing you're going to do too. And we're going to break that down here in a little bit. So the darkness is irrelevant. We've already put that there. Now, transparency is the first factor of good seeing. Now, transparency is referring to the clarity of the sky. And this is where you're going to get contrast. The contrast can be seen if you have good transparency. Now, I've observed at the Texas Star Party and the Grand Canyon Star Party. Those are two of my favorites. And the Texas Star Party is an excellent site, but it sits lower in altitude than Grand Canyon does. And there's certain objects that we've viewed from Texas that just didn't pop out as much as it did at Grand Canyon, and that's because the transparency wasn't there. Now, there has been evenings where the transparency at Texas has been amazing, and it's variable, so it's going to vary all the time when it comes to transparency. That's the tough thing with seeing conditions, is you're constantly chasing them. So good transparency is going to give you the contrast in the nighttime sky that you want to see. And actually, it has nothing to do with the nighttime sky at all. It's just the sky in general, because if you have good transparency and you're into solar imaging, that's going to make sure that you've got real nice sharp images. So what are the factors that affect transparency? That's kind of the big conversation, right? So high clouds, like all that cirrus and stuff, that affects transparency right off the bat. That can reflect light pollution, all kinds of stuff. It scatters light. Smoke is a huge factor. So last year, when we had a bunch of wildfires going on from California and basically everything was burning, a lot of smoke and ash went into the air. That ash affects the transparency of the sky. So it may have looked clear, but it wasn't transparent. So it affected the images. Dust is another big factor because, of course, it also scatters light. And basically anything that can scatter light is going to affect your transparency. So, like I said, high clouds, smoke, dust. Those are the big three factors that affect transparency when viewing either daytime or nighttime. So you want to find a location that has good transparency so you get that real etched look to the nighttime sky, and you want to get that detail. Now, like I said, transparency and anything that has to do with seeing is variable all the time. You know, there's a lot of people I've talked to that say, hey, I went out with my telescope last night and the image wasn't very good. Well, you can't get to know a telescope from one night out. The seeing is going to ultimately control the limitations of that telescope. So you could have just had a night that it wasn't a good night to view. Just because it's clear didn't mean those were the ideal conditions. And that's another thing, is if you wait for ideal conditions, you're never going to use your stuff. So do go out when you can. If it's clear, go ahead and go out and do the best that you can. But the more you use your equipment under different conditions, the more you'll actually get to know the equipment, and you'll know when, hey, tonight it's not really producing a great image because of the seeing isn't there. Where other nights when the seeing is good, it's like, yeah, this is awesome. I know when my telescope is working right. And that just comes with experience. But don't just go out with your brand new telescope, spend 20 minutes and say, oh, this thing sucks, and be done with it. You want to spend a couple nights. Go out for like 3 or 4 or 5 nights, as many nights as you can, and you'll find that the telescope will vary its performance night to night, or even throughout the night as things stabilize, and you'll get to know how your instrument really adapts to your local environment. Now, transparency is gonna, it's a night to night thing, but it also be hour by hour, so it is variable. So you can have good transparency early in the evening and have clouds come in later and totally destroy the night. It is variable, so you have to keep that in mind. Now, the next one is stability. Stability is referring to how calm the night sky is, or the sky in general. And this is going to really come down to how sharp the images are. Now, stability, of course, is affected by wind. If you have wind, it's going to look trashy. It's not going to look good. Heat is another big factor, and moisture in the air, another big factor. And moisture can actually be your friend for certain types of viewing, and we'll talk about that. Now, stability is highly variable, and we're talking minute to minute. So if a really good example of stability would be driving down a hot highway or a road, and you see the heat waves dancing across the road, and you see how it warps the images, and the telephone poles are all, boily and everything. That's stability. You're literally looking at seeing conditions in front of you. And on a good day, you want those images to be as sharp as possible. But because there's heat radiating off the ground, or your neighbor's house, or your house because it heats up during the day, or it's really windy that night and everything's moving around, the air is very chaotic. And that's what we're talking about when we're talking about stability. And stability, you can actually see if the night is calm or not, especially right now, because we have the bright star Sirius visible in the northern hemisphere right now. If you've ever gone outside and looked up at Sirius, and it always looks like a kaleidoscope where it's just kind of dancing around. But sometimes you'll notice that the star is actually really solid, and it's not dancing all that much, or that flickering effect, or scintillating is actually what it's called. You notice that it looks very still. That's how you know that their seeing is good. The less the stars flicker, the more stable the air is. That means you've probably got some pretty good seeing that night. So that's kind of a trick that you can keep an eye out for, is if you go outside and you see the stars are going crazy and they're sparkling and everything, it's really pretty to show your friends, but that generally means the seeing isn't very good that night, because there's probably some kind of wind, and it could mean that there's wind high in the atmosphere. The jet stream has a massive effect on how stable the upper atmosphere is going to be, and it's been really chaotic the last couple weeks, at least out here in the West. I think most of the US, it's been pretty chaotic because of the jet stream has dropped pretty low. And so the seeing has not been very good. We may have had some clear nights, but it's not stable. So, again, transparency is how transparent the sky is. And a lot of times, transparency is pretty good. Stability is the other factor. And that's something that's going to change regularly and affect your images. Kind of going through this a little fast, so we'll see if we can get this leveled out, but I'll leave more room for questions. So let's go through the different types of observing right now. So deep sky, a lot of these are going to be very variable once again. So deep sky has a couple different things that it can take advantage of. Darkness, of course, is the major factor. The darker the sky is, the fainter we can see stuff. The brighter those things are, the easier they are for us to take an image. So darkness, when it comes to deep sky, is probably the deciding factor for that location, but you also want to have good transparency. I'm a big fan of observing dark nebulas. Those particular objects require very good transparency. Darkness is helpful, but transparency ultimately is the deal breaker on how much you're going to see. So transparency is very helpful with that. Now, deep sky can also take advantage of stability, but not so much. There's a couple factors which we'll talk about here in a little bit about what ultimately all this is going to dictate. Now, planetary, actually, we'll just talk about that right now. So deep sky observing generally and imaging, generally you're taking in a wide field of view. If you're doing deep sky, you're probably not pushing the magnification too high. Most objects are probably going to look good about 100 power or less. You're not really asking a lot from the optics at that point. And you're not really asking much from the conditions at that point. As long as it's transparent and dark enough for you to be able to see that object, you're pretty good. Now, if you're really interested in high power viewing, stability is where that's going to become a factor, because as you magnify your object more, if everything's blowing around up there, then it's just going to look like it's boiling underwater. So if you have a location that gives you good stability, or you have a night that has good stability, you'll be able to push that magnification a lot more. So deep sky is fairly variable when it comes to seeing conditions. Obviously, the darker the better, but that's not a form of seeing. Good transparency is what you really want for deep sky, and that's why a lot of the research observatories that are doing deep sky work, they are generally at a location that has good transparency and good stability, and the darkness, it should be fairly dark, so they can reach the dimmer magnitudes and take advantage of the bigger telescopes without the effect of light pollution. But ultimately, major observatories want good transparency, good stability, and then if darkness is nice, that's great. So Mount Wilson out in California, just above Los Angeles there, it's not dark up there anymore. It's not bad. It's better than most of our backyards, but it is far from dark anymore because of how big the city is. But the seeing up there, it's very good transparency and very good stability. So even though they're not observing these ultra faint objects anymore, they do have some projects up there that take advantage of having good stable seeing conditions. So good transparency, good stability is best for deep sky. If you've got darkness, that's just a plus. Now, when seeing really becomes a factor is planetary. The biggest thing that I see when people get their telescope is, how big can I make the image? Well, that's kind of a loaded question, because it actually has nothing, it has a little bit to do with the telescope, but the deciding factor of your images looking good, besides the optics, because pretty much anything you buy today is gonna be fine. So transparency is good to have, and stability are the two major factors for planetary. Darkness, it doesn't matter. You could image a nice image of Jupiter or Saturn or Mars or Venus from the middle of downtown New York. It doesn't care about darkness because it's a bright object. But having good stability and transparency are going to be the deciding factors, because in planetary, you're generally amplifying or magnifying the image. And if your telescope has the ability to support that, it's only going to be able to do so if you have good seeing conditions to support it. There's a lot of discussion out there. You see a lot of people with, I want to know the Strel ratio of my telescope, or I want the biggest telescope I can afford. All those are great if you have the conditions to do it. A lot of times you'll see places, or let's say someone has a really nice refractor that's got like a Strel ratio of 0.99. It's perfect. If you're not sure what Strel means, it's a little number that they give out to give you the rating of the optics, how much light is going to the focus point, and kind of a percentage. 1 being perfect, which is never obtainable. So the best ones are 0.99. So 99% of the light is going where it needs to go. That's great. The thing about that is the seeing conditions are going to dictate how much you can get away with that. So all things being perfect, the optic is excellent. In space, the optic is excellent because there's no conditions that it has to worry about. But if you have the best optics in the world and you put it in a place that has bad seeing conditions, bad transparency, and bad stability, it doesn't matter. It's going to be not, I wouldn't say it's garbage, but you're not going to be able to take the advantage of that telescope to its top-notch performance. And that's what happens with a lot of our telescopes nowadays, is most of the locations don't really support a lot of these telescopes. I bought a Celestron C14. I love those telescopes. I wanted to use it for Planetary. I set it up in my backyard, and I found out very quickly that no matter what I did, my location or my backyard is not good enough to do planetary viewing with that telescope to the level that I wanted to. So I found an 11-inch was better suited for my location. Yes, aperture is nice, but if the seeing conditions don't support it, it doesn't matter. So, something to think about there. Now, that doesn't say get bigger telescopes. It's just you have to become more aware of the conditions that you're using it in. That's why when you're starting imaging, it's really easy just to get yourself like a 3 or 4-inch telescope, or let's say up to a 6-inch telescope, and they're really forgiving. The seeing conditions generally aren't going to ask a lot from that telescope, and you're generally using it fairly low power. Even when you're doing deep sky imaging, you're putting a big sensor in there. You're not really asking a lot from your telescope. So there's a lot of times where people want the best Strel ratio, the best optics in the world, and they're going to put this big old camera on the back of it, and you're not really asking the optic to do anything other than focus light to a point. So not saying that you shouldn't get the best optics possible, but more often than not, you'll probably find out you're not even pushing the optics to their capabilities at that point. So it's nice to have. Nice optics are very nice when the seeing allows it, but just keep in mind, 9 times out of 10, the stuff that you're doing isn't putting any demand on the optics. As long as it's diffraction limited, then you're fine, because that's generally what the seeing conditions are going to support. The seeing is always going to dictate what you're going to be able to get away with that night. So, but in planetary imaging, it is the ultimate deciding factor of how big of a telescope, how much magnification you can put on it to get a nice sharp image. That's what it's going to come down to. So that's why when you see people like Christopher Go or Damien Peach, they're imaging from locations that have very good planetary seeing. And that's how they're able to get away with using like a Celestron C14 or some big telescope like that to get those amazing planetary images. That's because the site that telescope is at can support it. So that's kind of hard, because it's like, oh, I want to go buy myself this big telescope because Damien Peach and Christopher Go are doing so good with it, and you get it, you bring it to your backyard, and the image doesn't look good ever. That's because your location just does not support that particular telescope. It has nothing to do with the telescope at all. It just is the confines and the conditions that you have to work with, and that's really important to get the best images possible, is understanding those conditions. Now, lunar imaging is the same thing as planetary. I probably should have put them together, but transparency and stability are going to be the big factors. The nice thing about the moon is because there's so much light coming off of that, a lot of it can get through. Now, a cool thing about planetary imaging and lunar imaging is we can use filters, and we've talked about this in our filter episodes. Is, let's say you're imaging a planet, or let's say you're imaging the moon, and there's a lot of heat coming off the ground, and everything's boiling, and it doesn't look good. At some point, it's just, the seeing isn't going to support it. But there's still tricks that we can do to help get rid of that. Now, when you're observing planets or the moon, you're generally doing it in color. And a lot of times, the heat and seeing conditions may show up in certain wavelengths, but not in others. So you can use a filter like an IR pass or infrared pass filter, which eliminates most of the visible spectrum and isolates just a particular wavelength. And that can actually calm the seeing conditions down, because you're eliminating a lot of the other part of the spectrum. So you're reducing the amount of light that's scintillating in the image. So if you are into lunar or planetary imaging and your seeing is not bad, but maybe you want to sharpen it up a little bit more, look at like an IR pass filter and kind of isolate that wavelength, those wavelengths down a little bit. It'll help produce probably a sharper image more often than not. And that picture of the moon on the screen, that was taken with a 7-inch refractor, an old Meade 178 that I used to have, and an IR pass filter. And the reason it's so sharp is because I used an IR pass. I was able to actually shoot it while it was high in the sky and the sky was blue. And I was able to cut all that down with the IR pass filter and give it a nice sharp image. So kind of a little trick that you can do. Now, it's not going to make up for bad seeing, but it can help if seeing's not too bad and you need to sharpen it up just a little bit more. An IR pass filter, if you're into Lunar or Planetary, is an excellent filter to have in the bag, and they don't cost that much. So solar imaging. Solar is a fun one to do, and it really takes advantage. Obviously, darkness is irrelevant when we're talking about the sun because it doesn't matter. We're talking the brightest thing in the sky. So transparency and stability are really good factors. And you see a lot of companies now, like Lunt Solar Systems, they offer like a 152, they offer a 230, and they offer a 300 millimeter H-alpha telescopes. And like with the Daystar filters, like the image that you see here, this was taken on in a Spree 150, full aperture. But what we find out is the seeing conditions during the day are probably best met with telescopes about 120 millimeters or smaller in aperture, because on most days, those are the telescopes are going to give you the sharpest image of the sun with the proper filters. That's generally what the seeing is generally going to support on any given day. Now, this particular day, it just kind of worked out that the seeing was good to shoot the sun at a full 6-inch aperture, but that's what happens though. A lot of people say, I want to buy this big telescope, and I'm going to buy a 30-inch Dob. It's been my dream, and I'm going to put it in my backyard. Okay, that's great. Go right ahead. What you probably will find is it's just not able to support, because the seeing conditions don't support that aperture. Lower power might work, but it's so variable, and every location is going to be different. But that's why it's good to go out and know what to look for. Now, there's a question out there, the best way to measure transparency and stability. There are ways that you can measure that. They're kind of expensive ways to do that. I like to go, and that's a good time to bring this up, I use clear dark sky a lot of times. This is just to kind of check the weather and what else is going on. But if you're looking here, there's different factors that we want to pay attention to. There's cloud cover, transparency, seeing, and darkness. And then, of course, they have smoke, wind, humidity, temperature. So these are all the bars that you're paying attention for. And this, I just picked an observatory hoping that they would have good seeing, but they don't have it. So the brighter the color of the box is, the harder that's going to be. So white on this generally doesn't work out well. You want it to be as dark blue as possible. So cloud cover right now out at Kit Peak, pretty good. Transparency looks phenomenal. We're at 5 out of 5 transparency, but the seeing conditions right now are not good. You see, it's probably like a 2 out of 5, maybe 3 out of 5 is what they're measuring right now. That's probably because there's high altitude winds out there. It's just not going to be producing the sharpest images for them tonight, probably because they've got some wind up there right now, and cloud cover can affect that. So the seeing conditions aren't good, but the cloud cover and transparency are excellent. And generally the seeing at this location is very good, but just worked out that right now it's not. That's because this is a variable, and you just have to pay attention to that. So if you're looking for how to find seeing conditions without getting some special seeing monitor, and a lot of observatories will actually have a seeing monitor where it'll analyze every night to check that. That's something cool to check out. Yeah, a lot of the major observatories, even our remote observatory, can check that out. And eventually you start, as you have a seeing monitor more often and measuring it, you're getting more data points. So throughout the year, as you take more data points each night, you're able to kind of calculate what your average seeing condition for that location is going to be. And you can say, hey, this one's really awesome, or hey, this one's kind of whatever. But yeah, most major observatories are going to have a seeing monitor somewhere that are taking those measurements constantly, and then they're jotting those down and probably graphing those out to best do that. So, but for amateur stuff, if you're looking for like forecasting and stuff like that, I just use the clear sky clocks. There are other weather apps that you can kind of see where the jet stream is. That's a good way to see if the seeing is going to be stable or not, because if the jet stream is really active over your location, it's probably going to require probably going to be producing some pretty turbulent air that night. So check your weather, look for the jet stream and stuff like that. But that's going to be, I don't have any links for that. I've got some friends who do, and I should have looked up those links beforehand, but there's a couple good apps out there to do that. And if you're really hardcore and you just want it, you can get like a seeing monitor. There's a couple higher end places that make those monitors that you can actually measure every night to check your particular location. But for me and most of our amateur stuff, just having, clear sky clock or something like that, that charts it out, a couple days at least, so you can see moving into the weekend out there on Mount Lemmon, where this telescope is based, they're not going to have good seeing up there this week. But as things clear out and calm down, when the jet stream kind of shifts out of this particular area, it should make that a little bit better overall. So something to look at, but that's just kind of what I tend to use up there. So let's go back to the real world and actually talk about what all this is going to ultimately dictate. So transparency and stability are the deciding factors of seeing. That's it. So, if someone asks you, how was your seeing? Don't bring up darkness. It doesn't matter at that point. So, and the more you go out and observe and you use your equipment, the more you'll come to understand your particular site. My backyard seeing is generally pretty good for deep sky work. Now, that's something I want to talk to you about really quick. I didn't put a slide in for this. I think we just talk about it. But seeing conditions are different between the type of observing you want to do. So, and we kind of touched on it in the previous slides, but let's go back a little bit further. So if you're into deep sky observing, you generally want somewhere that's very dry. The drier the air, the better the transparency. The higher the altitude, the better the transparency. Less air is better. That's why a lot of these observatories are on mountaintops. Generally somewhere in the desert like Texas, Arizona, New Mexico, California, Chile. All those places have extremely dry air. So they put those telescopes out there because the transparency out there is generally very good. You don't want a lot of moisture when you're doing deep sky work. However, if you're into planetary or lunar, having moisture in the air is excellent. The reason that is because when you have a lot of moisture in the air is really heavy. You might have heard of the Winter Star Party down in the Florida Keys. There are people there that just rave about how good the seeing conditions there are because of how dense the air is, because of the moisture in the air. When you have really dense air, clear, dense, high humidity locations, planetary viewing is generally pretty good because the air is so thick with all that moisture in the air that it doesn't move as much. So it makes that image for a planet very stable. So planetary and deep sky are kind of two opposite parts of the spectrum when it comes to observing. So if you're really into deep sky, you want a nice dark sky, hopefully it's higher altitude. It's an advantage with good transparency and no humidity. Arizona, where I live, that's usually the way to go. In the middle of the summer, there's no humidity in the air. I can't even fog the eyepiece about an inch from my mouth to clean it without it evaporating before it hits the glass. So, low humidity, excellent for deep sky. High humidity, excellent for planetary. So, work something out in between theirs that way. So, that's how seeing generally works with those two. Now, good seeing, so good transparency and good stability is going to allow you to do higher magnification. So if you're one of these people who really likes to just blow up a planet as big as you can, higher magnifications are going to be achievable when the seeing is good. Now, we'll get into it in a minute. So yeah, higher magnifications are attainable during good seeing. Larger apertures. If you have that dream telescope that you've been working on, you're going to need a sight that's going to support it. There's a lot of people out there that I see owning these less expensive Ritchie-Chrétien telescopes, which are very nice, but the problem is they're longer focal lengths. And a lot of the camera sensors that are out there right now have small pixels, and they don't match up well with these telescopes. So generally you need to bend them like 2x2 to make the pixels bigger, so it better matches up with your seeing conditions. And when you have longer focal lengths and bigger telescopes, it amplifies the seeing even more. So you might notice if you see some people imaging with these larger aperture telescopes, you might notice that their images might be a little on the soft side. That's because the telescope isn't matched up with the seeing conditions, as opposed to something that's in an ideal sight, giving you that sharp, detailed image. Now, if you want to have one of those longer focal length telescopes, you can still do it from your location, but you might need to pay more attention to matching the pixels of your camera up with the focal length in order for it to match your location. So, for example, if you have one of these high megapixel cameras and you're putting it on the back of, a 2000 millimeter focal length telescope, and you do the math, and it says that your image scale roughly is like 0.7 arc seconds per pixel, it's probably going to look a little soft because your location doesn't support that seeing. There's a lot of places that do not support seeing of that caliber. So if you bin your pixels, let's go 2x2 on that same setup, now you're at like 1.4 arc seconds per pixel. That's more true to say of something in your backyard, probably on a good night. Most people I talk to, their image scale and their seeing conditions probably support somewhere between 1.5 and 2.5 arc seconds per pixel given their location. And that's where it's kind of funny. So if you're auto guiding and you're saying that, oh, I want to auto guide at 0.5 RMS, that becomes completely irrelevant because your location doesn't even support that resolution. So if you're fighting a mount and you want to get your mount down to 0.5 arc seconds per pixel, which is awesome, but your telescope system at your location only supports 2 arc seconds per pixel resolution because of the seeing, you could be guiding at 1.2 RMS on your mount, and it won't matter because you cannot resolve that small of an image from your location because the seeing is dictating it all. So yes, you can get a nice big telescope in your backyard. It'll look great, but if you're going to spend the money on that, you need to make sure that you're probably matching up the camera to support your location to get that sharp image. So that's why using these 6-inch and smaller, we'll say 8-inch and smaller telescopes is generally more forgiving because they generally match up with pixel sizes of these cameras better and better match up with your local seeing better, giving you a nice, sharp image to show your friends. So that's how that all plays out. Good seeing is also going to give you more contrast. So if you're imaging the planets, you want to get all that cool contrast and detail in there. Good seeing supports that. Sharper views. You want to have a sharper image with your telescope. Good seeing supports that. Sharper images, same thing. And of course, better guiding. If you want that nice, tight guiding that you're looking for, seeing conditions are going to dictate that. So if you're imaging too quickly or you're guiding too quickly, you'll actually be chasing the seeing conditions, and your guide graph's going to look like a heart attack going on there. If you do longer exposures, sometimes it can smooth it out a little bit and give you tighter guiding. A lot of these are highly variable things, though. So just because we say it here doesn't mean it might apply to your setup. So you're going to have to play with it. You have to adapt to your location, and no one's going to be able to do that for you except you. So it's going to require some experimentation. And of course, higher resolution imaging. You want to take really high resolution shots, you better have a site that's going to support that piece of equipment. So, for example, this is the 10-meter Hobby Eberly telescope in the McDonald Observatory in Texas, currently under snow. This particular telescope has been picked for this location because they have good enough seeing to support the telescope's role at this particular location. You can't take a 10-meter telescope and just plop it wherever you want. You have to adapt it to the particular location. That's why Mauna Kea has Keck. Down in Chile, they have all these other big telescopes like the Gemini, the LSST. All those telescopes are there because the seeing conditions meet all the major criteria for that location. So that's pretty much it for the day. If you like what we do here, go ahead and subscribe to our channel. If you like what you see here, if there's something you want us to cover or miss something, you can email us at support@skywatcherusa.com. Title it What's Up so we know it's about the What's Up webcast. And we'll be happy to take a look at, maybe future topics. Now, next week is going to be probably one of our biggest episodes yet. We're having our good buddy Don Pettit. Don is a NASA astronaut. He's been to the ISS 3 times. And don't ever get into a photo competition with Don. I know all of us as astrophotographers are like, hey, look at my image, blah, blah, blah. Don will destroy you every single time because he'll probably have a picture of something from the International Space Station and it just dominates everything. So Don's going to be here from Houston next week. He'll be coming in or virtually joining us next week. We're going to talk to him about what it's like to be flying on the ISS. How he got into space, and so much more. So you want to join us next week because we'll have him here with us. So we're excited to have him next week. So join us next Friday, 10 a.m. Pacific, right here at the What's Up Webcast. If you can't join us, it's always recorded on our YouTube channel. So that's that's the wrong slide. So disregard that. So thought I'd change that. So that pretty much wraps it up. So that's how seeing conditions work. They are the ultimate dictator of how good things are going to look in your particular location. So definitely start paying attention to those. If the more you pay attention to it, the more you understand it, it'll make when you go investing into better equipment or higher resolution equipment, it'll give you a better base on what to purchase, what's going to work for your location, and that way it's going to give you the sharpest views possible to share with others. So that's pretty much there. So if you guys have any questions, go ahead and ask those in the chat. If we don't really have anything, then we'll go ahead and shut it down. Real quick, if you do like what we're doing here, and you want to get some shirts or swag, we do have the skywatcher.threadless.com. We've got shirts and all kinds of stuff up there, hoodies. You can kind of mix and match whatever you want there. So that is our swag store. We'll probably be adding more stuff here soon, but have to mention that. My head is in the way, so sorry about that. There we go. These are just some of our offerings on there. If you want to check those out, that just goes to supporting the webcast as well. So that is our skywatcher.threadless.com stuff right there. So awesome. Well, I don't see any questions. I think we answered most of the questions already for today. So thank you all. We are ending a little bit early today. If I missed anything, go ahead and email us at support@skywatcherusa.com. Thanks for being here. Have a happy Friday and a great weekend. And hopefully, now that you know about seeing conditions, you know how to take a look at how to make your stuff the best it possibly can. So, thank you very much, everyone. Have a great weekend. Stay safe, and we will see you guys next week for Don Pettit and the What's Up webcast. So, take care, everyone. Be safe. Clear skies.